All right, welcome back. I hope you're having an awesome time so far. Our next speaker is Jun. He's a senior manager machine learning at Goldman Sachs. Please join me in welcoming to our virtual stage.
Okay, thank you for the introduction. Okay, and then let me share the screen first, and then we can go from there. Okay, hi, good afternoon, everybody. Welcome to this technical session. Okay, this is my honor to share with you my talk. The title of my talk is From Tech to Finance, a Machine Learning Engineer Perspective. My name is Jian. I'm the head of Machine Learning in Knowledge Management in Goldman Sachs. Okay, so this is my agenda of the talk. We'll talk about myself briefly, and I will share with you why I want to deliver this talk for you. Second, we'll talk about machine learning algorithm and application, and we'll talk about machine learning algorithm application for finance. And we talk about finance environment. We talk about how to get yourself ready to prepare into the machine learning for finance. And we talk about machine learning trending and the tips and pitfalls. Okay. Before the talk, I want to make a disclaimer is that the content of this talk do not offer neither imply any Goldman Sachs investment strategy, also did not offer any priority of the Goldman Sachs machine learning strategy. This is the purpose of this talk is to share my experience and vision to the technical community. For Goldman Sachs investment strategy or client commitment, please refer to Goldman Sachs official statement or the press release. Okay, before we talk about machine learning or artificial intelligence, this is the AI for Finance Summit. So this is artificial intelligence, but people also talk about machine learning. So the term may be confused. So I believe the AI is a superset of the machine learning. Okay, the AI has been first proposed in 1956, and then in the beginning we talk about rule-based. Okay, and then we talk about the data-driven approach. And rule-based, the good thing is this low initial cost, okay, but it may have more challenge to make it scalable. But the good thing is it's easy to handle exception scenario. But today there's more computational power available, there are more data available, so people tend to be different, try to go to different approach. For example, I mean in 1959, Arthur Samuel mentioned that the machine learning is a field of the study that give computers the ability to learn without being explicitly programmed. So it means there's no rule there. So we want to using statistical approach to make sure we can teach machine to do the thing we want to do. So today, because of all the computational power and the data, people are more into the data-driven approach. So AI and ML, they are interchangeable in the community. Okay. So before we talk about machine learning for finance, let's talk about algorithm. There are so many algorithms available in the community. So, and then people try to categorize this algorithm. So this is one way to categorize. So from here we can see there's a machine learning, there's a supervised learning, the unsupervised learning, and the reinforcement learning, and there's a regression, blah blah blah, so many things. And then there's classification, and then forecasting. But if you look at that, we don't even see deep learning or natural language processing. We are not trying to challenge how people categorize it. We just want to show you that there are so many algorithms available. So if you don't know a lot, that's okay. We don't expect people to know every algorithm. Even if you know 25% of algorithm, you should be very proud of yourself. You can keep your head safe. You can see yourself as an expert in this field. Okay, so this is algorithm. So when this algorithm, how do you leverage this algorithm? Do you want to implement by your own? You want to call the open source library? As today, people typically could call open source library. You have Python, you have R, you have MATLAB, blah blah blah. So we have so many things available. So you can do. So after we know the algorithm, we talk about application. So there's many applications can leverage machine learning. Okay, so AI is everywhere. But so people also take a step to see, okay, what kind of application has been applied by AI? So if you look at that, look, the financial application is not even here. So you can see that AI is everywhere. So in this talk, I'm going to share with you a few algorithms which can be used in the financial community. Okay, so we can separate into the front office, middle office, and the back office. Okay, So when we talk about machine learning in the front office, of course, we need to talk about quantitative trading, right? So how can we use AI for the trading? Okay, so here I only can show you a few algorithms. This is not all the algorithms. I show you a few algorithms to lead you to the door, and you can do your further research. So one way to do is called simplified pair trading algorithm. So you can find a few security. They are highly correlated. For example, in this case, would be American Airlines and United Airlines. They probably go up and down together in the same time, or very similar. So if we know one security is deviate to the other one, that's arbitrage. Okay, so if one the security is more expensive now, so you can see, should I buy it or should I sell it, right? So in a pair trading algorithm, actually, we prefer to sell it because eventually when this security going expensive, they'll go back to normal. They're going cheaper later. So when it gets go high, you probably need to sell. But this one strategy you can implement by your own. But in a pair trading algorithm, so what you can do right now is by looking at the chart, it's not easy to see. But if you can reformulate this data into the spread by subtract these two, security, get the spread, and somehow do normalization by Gaussian distribution, and you can categorize your spread by, one or two standard deviation, right? So if one security is 1.5 or one standard deviation above the other one, and you should sell or you should short. If it's under, you should buy. So this is pair trading algorithm. Okay, it's very, very straightforward. And this is, so another way you can apply this trading algorithm into fixed income. Okay, so in the fixed income space, people typically want to know, does the spread is tight or narrow, right? So they typically say they draw a line, which is their index, and then they compare each individual. They compare each individual, fund to know, are they cheap or are they expensive, right? So you can treat this as generalized pair trading algorithm, right? So you can know so whatever is above the line is cheap, below the line is expensive. You can find all my talk. I have all the reference in the bottom of my chart. Okay, so I can identify your investment strategy. So after you talk about the return, we also need to talk about volatility. We don't want to pursue the highest return. We want to pursue the highest return based on the unit volatility. People also call it the Sharpe ratio. So you can start to formulate your equation into this space by using the pair trading algorithm. Okay, another way of the trading algorithm is called simplified Bollinger Band trading algorithm. This one does not require two security, only one security. You want to basically compare the 20 days or 30 days moving average, and then if the price is over the 20 days moving average, it means probably it's more expensive, so you should sell. And if it's below 20 days moving average, okay, or two standard deviation, you should buy. This is one algorithm. You can also define your own. If this is over, if it's right now the security is booming, you should buy. It's up to you. It's up to you how to you interpret your data to lay out your strategy. So that's another very simple example by using the Bollinger Band trading algorithm. Okay, so another space by the trading, you can use the sentiment analysis and the natural language processing for trading. So we know the market has emotion. So if you can catch emotion, you can use emotion as signal to integrate with your trading strategy. Okay, so you can talk about emotions. You can do it by the sentiment analysis. You can do the document or paragraph or even sentence-based sentiment analysis. You can do entity sentiment analysis. But when you do entity, for example, you want to know is iPhone is good or bad. It's probably good. You can analyze this. But in the end of the day, you want to know iPhone actually related to Apple. So every sentiment analysis you need to aggregate into the issue space, right? So also, how do you know you want to analyze iPhone? Why not analyze the different things? For example, iPad mini. Okay, so which one is more important? You probably need to do the topic detection to know what is the most important topic being addressed in the market. So you analyze that, you run the sentiment analysis based on all the hot topic, and then you aggregate into the issuer, and you can somehow integrate the sentiment information signal into your investment strategy. So by rule of thumb today, people think that the market impact on sentiment may be very short and instantaneously. So it happens very fast and die down. Okay, that's the experience people think. You can verify to see does this make sense or not. Okay, so after we talk about the front office, we can also talk about middle office. Okay, in here I want to use an example of the entity resolution, and then to talk about how machine learning can help on entity resolution. And then so entity resolution is that you have your knowledge space, you have knowledge base, and you have a lot of documents. You want to search Apple. Okay, so you can think that very well-known search framework can help you on that. So you can think entity is a document, okay, and your query is whatever you want to ask. So the probability of the document given by the query, okay, that's your mathematical framework. You can be reformulate into the likelihood function times the prior distribution. Okay, so by reformulate that, you can do this. And then typically when we do a search, we are only interested in the rank index. We probably don't care the score. So we can say the document or the entity is the argmax of your document based on your query, and you can reformulate by the maximum likelihood by your likelihood function times the prior distribution. That's a search. Okay, that's fantastic. But the things is not like this. So if you want to search Apple, but in your thing, we have Apple computer, we have Apple hospital, we have Apple bank, we have big Apple. So which Apple you are talking about? We don't know. So the existing that search framework may not be the best to solve your problem. So how can we address this problem? So what we can do is if we can provide additional, heuristic type. For example, I search for Apple. Also, I want to know for something related to price. I know this is related to Big Apple. This is New York City. If I know I want to search for Apple and also finance, and this will be returned as Apple Bank, it's not returned for Apple Computer. So how can we do that? So we can reformulate our equation into what? Into a given the query and the document type, and you give me the best the index of document. Okay, so this is search. So right now we put the heuristic type here. So after we reformulate that, we're using the conditional independent approximation. We can make this equation into this way. So they will be equal to your original likelihood function times your prior distribution times your heuristic type based on your document. So there will be original search score times the second term. So based on this thing, that will be easy to address by adding the heuristic type. You can solve this problem so you're not always getting Apple computer anymore. You can get Apple hospital, Apple bank, Apple big Apple, whatever you want. So this is the way to handle the entity resolution. But another way to handle entity resolution is you can use knowledge graph. For example, you talk about Bill, okay? So we want to talk about Bill. Is it Bill Clinton or Bill Gates? You don't know. So it's difficult when you talk Bill, so many Bill. But if you talk about Bill, talk about Ice Bucket Challenge, talk about COVID-19, you probably know this is the Bill. This is the Bill Gates. This is not Bill Clinton, because Bill Gates make a few speech about his vision about how to handle COVID-19, and here he has a YouTube. The video about Ice Bucket Challenge, right? So if you can build our knowledge base, okay, to take all the information into knowledge base, you traverse knowledge graph, you can find out actually that's Bill Gates, okay? So that's the way to do the entity resolution without you to go to search space. It depends on the problem you want to address. Okay, you can use different algorithm to address your problem. Okay, the last one we want to talk about back office. Okay, so if you are not interested in trading, if you're not interested in middle office, if you are interested in, for example, the IT service stacks are essential for all the company. Every company, they have IT, they have a help desk department. They want to do IT ticket reduction, root cause finding, whatever, blah, blah, blah. So IT help desk has been evolved recently. So they start to bring in cognitive technology, they have automation, they have a chatbot. So this is a new field, okay, it can apply to machine learning. Also, you can also, if you are interested in the control your office temperature, how to optimize your energy consumption, you are building an analysis, something like you can also apply a machine learning in the office operation. Also in the finance, they have internal auditing and compliance. They can be all use machine learning to help them to solve their business problem. So machine learning for finance, there's opportunity all over the places. You don't need to focus on trading if you don't want to. Okay, so that's a lot of opportunity there. So I want to share with you the next slide is about the finance environment. So in the finance, they have their basic knowledge, which is financial knowledge. Okay, so when you work with them as a machine learning expert, okay, you need to, I think, work very closely with your stakeholder, okay, because you need to convert their knowledge into mathematical framework. Okay, you don't want to just blindly working on your algorithm and then hopefully they can take it. It doesn't work this way. You need to work with them very closely. So you need to focus on your business requirement instead of your algorithm. Okay, that's very important. The second thing is in the financial, environment, they are sort of more close. Okay, so you probably cannot access public cloud because the data always needs to stay in house. Okay, because they are more close, they may have their own implementation, their own open source build. So if you want to do pip install in the Python, you probably pip install your internal house that the open source. It's not really Python open source because you may not be able to go outside to download a package. Okay, of course the upload download GitHub can be a challenge. Okay. Okay. Also, there's one big difference is that in financial sector, a lot of people they provide VM. They don't give you your personal laptop. Like IBM, everybody get our laptop. So when we go to a meeting, we bring our laptop. So we are reading our email. We do a lot of things. But in finance, when you give you a laptop, when you go to a meeting, you go there. You don't have your machine. So you go to a meeting. So you fully participate in the meeting. You cannot access your email. Okay. So this kind of thing, you make the working offline is extremely difficult. You want to do your PowerPoint, you want to develop your Python. It's not easy to do offline. It's just the environment you need to be aware. Okay. Okay. So after this, I want to spend a few minutes to talk about how do you get yourself ready to moving into AI for finance. Okay. So again, machine learning for finance, they are probably all over the places. Okay, there are also opportunity for everybody. So, but the opportunity is not for machine learning model developer only. It's not for machine learning data scientists only. It can for everybody. Knowing your strengths is very important. Okay. So if you are a software engineer, okay, you can work on the machine learning SDLC, machine learning model development, deployment, or maintenance lifecycle. You can even work on the engine to make the engine more robust, that it never die, or when it die, you can start over. And you can even do your tool modulation. I mean that all the scientists they suck in writing their code, so you can factorize their code to make it easy to maintain. So this is what you can do as a software engineer. As if you are infrastructure engineer, you can make the things more scalable, okay, or even more stable for infrastructure space. You can try to develop 100 machine learning engine, okay, ML engine or ML services, or you can even work on the container-based AI platform. So there are so many different opportunities. And if you are UI UX expert, you can design your system to make the AI more consumable with your end user. And if you are machine learning engineer or scientist, of course you can continue to develop your algorithm, okay, or develop your model. And if you are machine data engineer, you can do the ETL or data warehouse. There are so many opportunities. Don't limit to yourself. So that know your strengths, you should be able to join into the AI space easily. Okay, so we're going to spend a few minutes talk about the trending. This is purely my vision. Okay, so People in the past been working on the automation for a long time. We want to automate this process. Okay, so that machine learning can help you to automate this. Okay, but because information right now is all over the places, I think that people may not be able to digest so much information. So I think the recommendation will be gradually taking place. Okay, look at that today. When you go to Amazon, you go to Netflix to buy a product or to search a movie, you probably don't search by yourself. You rely on the recommendation from the vendor. So there are 10,000 bonds today, 5,000 different equities. Okay, which bond you want to buy, which bond you want to sell. Okay, which equity you want to buy. So if we have a way to do a screening to recommend, okay, this 10 bond, you can take a look to buy or sell. So, and then this recommendation simply provide the analysts, they can do the further research to confirm this signal. This definitely can help in the investment process. So you don't really heavily rely on automation. You can put people in the loop to help you to your investment strategy. So I believe the recommendation will be gradually taking more and more, important in this space. That's what I think. Because before I conclude my talk, I want to give you a few tips and pitfalls that you can leverage from our experience. The first is you need to take every opportunity to test your system. Okay, so for example, recently we've been using the Nelson Siegel savings and package to develop our model. Okay, so on the bond space, but then we use different way to test our system. Finally, one day we find out that our Nelson Siegel savings and package sometimes give us different result by different setting. So it turns out that if we arrange our data in different way, or even it's the same data, we get different result. Okay, we never know until we fully test our system in a different way. And so this is more like a bug. Okay, of course, when you find a bug, we can solve. We can sort our data so we can make sure every time we call this package always on the same sequence, so we can get consistent result. So the lesson learned is there's so many things. When you doesn't get a call dump, it doesn't mean your system is working. If you misplace a plus sign by a minus sign, or you misplace your parentheses, your program still work. Okay, but you may get something unexpected. The result may be incorrect. So it's very important you always double check your result by always using different ways to test your system. Okay, the second thing is you want to understand the algorithm implementation. For example, we know feature normalization is very important, but you say, oh, I never need to use that in a decision tree, or I never need to use the feature normalization in the regression, because they do that for you in regression. In decision tree, because they're using, maximum initial information. So the feature normalization is not necessary. But in SVM, that will be critical. If you don't do that, your result will be off. Okay, so also in the deep learning neural network, you need to do your feature normalization, otherwise your result can be off. Okay, so you need to understand how the algorithm has been implemented, so you will not misplace or misuse your algorithm. The third thing, you need to understand how algorithm is designed. For example, if you want to do a feature selection, you can do using the feature permutation to do feature selection, or you can do always add one or remove one to do feature selection. And why they have a different design? Because the feature when you do a feature permutation, you typically use a case that if you don't have training data, they only give you a model, so you cannot return the model. So you permutate the feature. You know which feature is more important, which feature is not important, so you can adjust your model. But if you have your training data, you don't need this way. Okay, you can use a standard way. So understand your algorithm design that definitely can help you to leverage the algorithm. The last thing you want to say is that 80% of the time we spend in our daily process is used for the data pre-processing. We don't do the model development. Only probably 20% of the time we spend on model development. So don't feel frustrated if you spend a lot of time to do the data pre-processing, because that's the nature of the work. Okay. So the next thing I want to share with you a few tips. How do you develop the Python library? How do I develop Python library? Okay. We know the Jupyter notebook is very, very popular. It's very powerful. It's very convenient. But just be careful. Sometimes you may run into a trap due to a global variable. Okay, here is an example. So if for example, I define the add a very simple function by adding two things together, but when I return A plus B plus C. We know this is a bug because A never been defined. But guess what? When I run this, actually it works. Because what? Because I defined A equals 3 long time ago. Okay, so A is there. So when I do A equals 3, when I do add 2, 3, I return A. Okay, so this is a bug. If you do this way, you may be trapped. Okay, so I believe that another way to do this, you write your function into a library, into a module. So I put adder into my base utility module. So I import as BU. So I put BU.adder 2, 3 is equal to 5. So I know when I use this function, my function is going to fail. Okay, so I know I can fix my bug. So it means if you want to develop 10,000 lines of the Python library or system, it's probably you want to do the modularize as an external library and using your IPython notebook just for testing. This is just our experience to share with you. Okay, again, I want to just to reiterate the disclaimer. I always say that this does not offer any Goldman Sachs investment strategy or our priority. I only want to share with you with my experience to the community. Okay, this concludes my talk. So open for any question and discussion. Thank you so much. Any question?
Awesome. Thank you so much, EE. Thank you for sharing these insights with us. The audience is giving you a huge virtual round of applause.
Okay, thank you so much.
Thank you. So for the audience, it's time for you to make your way to your next session. And along the way, make sure to accept your connection request and check out our amazing AI exhibits. Thanks so much, and we'll see you around.
Okay, thank you. Okay, bye-bye. Thanks.